I like to tell my family I work at the email factory and producing emails all day long. And truth be told, I also get to do spreadsheets. Uh, but very rarely, I still get to do some technical things. So I'd like to thank everybody for allowing me to talk a couple technical pieces on Pelican. No big picture, here's the philosophy or the understanding of things, but just a little bit of nitty gritty. And of course, for those of you who have met or worked with me before, you all know I work exclusively at whiteboards. So having this in slide format is somewhat restrictive. And also, as I started writing down all the things that I wanted to talk about and all the interesting technical, clever things that Pelican does, I realized HTC24 is only 1 week. So I'm attempting to go over 3 different items. These are 3 that I thought would be interesting. You'll have at the end some opportunities to throw tomatoes at me and say, here's the thing I really wanted to see instead. And that will, I think, inform HTC25. So first topic, HTTP everywhere. So I think I mentioned yesterday that really underneath the hood, we try to use as much as we can hew to standard protocols. So if you want a standard protocol that moves bytes across networks, it's hard to find one that's more ubiquitous than HTTP. So that's indeed how Pelican moves bytes, actually, between the client and the cache or staging server, the cache and the origin. Everything within the ecosystem moves over HTTP. I'll talk a little bit about the clever things that Pelican client does. But when I say HTTP, I really mean it. If you want to read a very small text that you might need binoculars for, if you don't like the Pelican client, use curl, use wget, use the Python request library. Any HTTP client will do and work with the ecosystem. But I'd like to say that if you use the Pelican ones, we have some nice value added on top. So if you're downloading an object, it's a HTTP get. If you upload an object, it's HTTP put. The idea is there's really no surprises there. As I mentioned yesterday, we're still transitioning some services in the OSDF to Pelican. So there are a couple gotchas here, but I'm certainly hopeful that if you fast forward to 3 months, that this will all be true. So what does the example request look like? So if I have a particular object name, so here's my object name, and you write out a HTTP style request. This is what curl creates when it's actually going off and talking to that director service I mentioned yesterday. So we have our object name. We were using the get verb. We pointed at the particular director. Of course, this is something that curl accepts or automatically generates. If you are familiar with HTTP, this is pretty bog standard request. There's nothing special here. Then you get back a whole lot of stuff. So this looks a little bit heftier than what you see in a particular HTTP request. But I wanted to color some things that are bog standard, right? So, yep, plain that. So 307 for those of you that have not quite memorized all your HTTP status codes is a redirect, right? The director, if you remember the architecture diagram, doesn't actually deliver data, it just tells you, here, go use this service. I think this cache might be the one for you. So it responds with a redirect. It responds with some standard content type and date headers. And then the redirect actually needs to tell you where to go. So I was generating these slides somewhere over there, and decided that the nearest cache was on the UW-Madison campus. And again, all these different headers are all standard things that any of your HTTP clients will understand. There's a couple things that aren't as common for HTTP clients, some that we've added for Pelican and some that are lesser known RFCs. So the director also informs us a couple things like if you are making this request to the cache, here's the kind of token that you're going to need. So if you're using the standard client curl, it's up to you to figure out all the authorization stuff. But these additional headers tell the Pelican client what kind of token you need. If you don't have a token, maybe this is an issue where you can go to get it. It handles things like retries or eludes the need to go back to the redirector for certain requests. So these are kind of part of the value add. So these are all HTTP extension headers. And this is one that's a standard from HTTP that says, here's a list of different services that you're allowed to use. So if I ask the redirector, this is an object I want, it's going to respond back, here's where you should go get it. But oh, by the way, if that doesn't work, here's plan B and plan C. Some clients will do that. The Pelican one certainly does. You can also skip it and still have a perfectly working system. So if we instead think of the deeply technical, here's how HTTP requests look, but go to the how does the architecture and who talks to what. Again, the client starts off by talking to the director. It says, director, I want to get this file. Who can provide that service for me? And that's where it responds with that, again, that HTTP 307, where it selects, hey, this is a cache I think you want to work with. So maybe it decides the UW-Madison cache is a great one. Maybe it says, oh, by the way, I recognize that file. It's nearby in Chicago. Forget UW-Madison. Go use the Chicago cache instead. Some amount of logic happens here, and the client stays relatively dumb. It just does what it's told. So in this particular pictogram, the client gets told to go here. It repeats its GET request for the object. And here, the cache has to make a decision. So one possibility is cache has the object, and it just starts streaming back data. And you get exactly the things you asked for. And of course, that's maybe the less interesting case. What happens when there's a cache miss? Now, the cache itself also has to go back to the director and say, hey, I need this particular object that Brian asked for. Where do I, as a cache, get an object? Cache goes to the director. It's, again, a HTTP GET. The director makes some magical decision. I'm not going to tell you how it makes that decision right now, but it decides, oh, dear cache, there's an origin over here, maybe in Kentucky, and that's going to be the place that you're getting your object from. So it's, again, this HTTP 307 redirect. The cache repeats its activity going to the origin, and the origin, ideally, has the object that we want, and then the object finally gets returned to the client. And again, the whole point of what we're trying to do is, even though we have lots of logic on how we selected this service, why we selected this service, maybe the client has special logic around retries. If you look at happens in on the wire, it should look comfortable and familiar to anybody who's ever used HTTP before. And that's really our goal, is to make this as accessible to as many pieces of infrastructure and maybe just work better if you use the Pelican ecosystem. I drew the last picture as if the director blindly redirects the cache to the origin. In reality, there might be multiple names or origins for the namespace. So we talked about the LIGO case yesterday. Maybe the director decides, I know these two origins are both part of LIGO, and this is the better one. And the director might decide to issue actually head requests to the origin to make sure the one that it thinks is good is still alive. It has some amount of logic, which might even require additional HTTP requests to make that decision about where to use it. Another option that we really didn't talk about because we've been focusing on the HTC context is what happens if we only want part of an object? What happens if I have a particularly interesting use case is if I have a big netcdf file and I just want this geographic region, or I just want the temperature data, I don't want the other petabyte or so. It turns out that everything here works at the byte range level. And particularly the requests from the cache to the origin happens in chunks in parallel. And so the client starts responding, or the client starts to get the response back from the cache as soon as the cache gets those first bytes from the origin. So in the extreme case of we have a petabyte object we want to download, we're not waiting for a petabyte to move. We're really waiting for that first 64 kilobytes to move before the client starts to get some data that's interesting. And again, the HTC case, when we're preparing input sandboxes for a Condor job, we probably want to move the entire object anyway. But if you're thinking some of the other use cases like visualization, right? If I have an 800 terabyte data set for NASA, I don't want to move that 800 terabytes into my browser. I just want to look at the little bit. And that's why we actually end up working at the byte level of objects and not always the full object. We have a few, or maybe more than a few, XRD experts in the room. So for those of you who speak XRD, here are the different pieces and things that plug in. Those of you that don't speak XRD, I think there's some email waiting for you in front of you. And we have kind of the standard XRD setup for both caches and origins. And really all Pelican is doing is starting up a particular configuration of XRD right now, and XRD is moving the bytes. And really the only piece in all this that is different, I probably use bad coloring here, is we have one small Pelican plugin in the cache to make sure it understands how to interact with the director and talk to the origin. So 95, 98%, I'm making up numbers right now, but the wide majority of the code in terms of what moves bytes are shared with lots of other communities. And we've kept, in at least the data movement path, the Pelican specific pieces pretty small. Second question. I have an origin that I claim has LIGO data. Frank has an origin that he claims has LIGO data. Who has the real data and how do we decide who to trust? So remember our discussion from yesterday, we actually have two central services, the director that directs the traffic and selects services. And I also mentioned that we have one called the registry, but I didn't explain that much. So the registry helps us manage this namespace and relationships of all these different services within the OSDF. So just because you come up and tell me that you have an origin and you're happy to serve the LIGO namespace, that doesn't mean that I'm gonna let you start loading up the caches with your malware or whatever else you have. So the first time you start an origin, the very first thing it does is creates a public key, private key pair. And according to its configuration, they'll reach out to the registry and say, hey, I want to serve LIGO data, and I have a public key XYZ. Now, this is where you have some business processes, and somebody has to decide this request is either valid, and we should approve it and record it, or we decide it's invalid. And we can connect it to CI logon identities. We can do all sorts of automated flows. But in the end, there's some business process of either the human decides LIGO is a real thing, let's approve it, or no, this looks suspicious. As always, we draw on slides that the happy case where we decided this is actually LIGO and the real origin, and we write down that association in a small database. Now when the origin comes to the director and says, hey, director, I am the origin, I offer some services. I'd like to serve up the LIGO namespace. Anytime people want LIGO objects, you can come to me. The director says, well, that sounds nice, but prove it. And the way we prove this is the origin using that public key signs a small token that says, this is an origin for LIGO, signed public key XYZ. The director looks at the token, talks to the registry and says, hey, I have an incoming token from XYZ. Is that really LIGO? The registry will look up in its database, decide yes or no. And in this case, I drew the okay, everything worked. So in the end, the Pelican ecosystem creates these associations between a public key, private key pair and a namespace. Only way that you can serve that namespace or join a cache or join an origin to the ecosystem is to have an approved public-private key pair. And that's how we help manage the namespace. That's how we help decide which services are legitimate and which ones we don't allow in the federation. Finally, I wanted to mention a couple things about the origin to object store, because this is something that often gets confusing. So we take this picture of the origin and kind of expand it so we can write a couple more things inside it. Anytime we have a request coming from the OSDF, we have to review that request and decide either to authorize it or deny it. Some cases we've configured a namespace to be public, so we always authorize it. Some cases we decide this particular namespace needs to have a token from this entity, from LIGO, from IceCube, from CMS, whoever that might be. And that incoming request, we take a right turn and go through the authorization system and double check this is one of the configured real origin or real tokens for our namespace. However, after that authorization occurs, that request goes into the backend, and the backend, in the X-D terminology, OSS, that plugin has to decide how to talk to the object store. So if you're a POSIX file system, how do you talk to a POSIX file system? You say open, call, and you read, close. If you're a more complicated setup and you have multiple users, for those of you who remember your Unix design class, you say set UID, use this credential for user ID 1234, and then open, read, close. If you say are a S3 instance, instead of open, read, close, you might reissue get with a separate token associated with that bucket. The important part is once this authorization is done, whatever credential we decide to interact with the object store is completely independent. We already authorized it, and the rest is just that interaction and plugin. So the moral of the story is we actually have two independent parts. One is how we talk within the data federation, and then secondly, how do we interact with the object store? All right. So again, I will happily bore you for hours on all the interesting technical aspects of Pelican. These are the first three, and I hope that kind of gives you the feel for the sorts of system we're building and kind of some of the designs we're attempting. A note, this is the first presentation, the first time we tried to start popping the hood and explaining things to folks. So I'll certainly welcome feedback on what else might be interesting to the crowd. And thank you.
Thanks, Brian. Questions from the crowd?
When you are talking, so authorization being split between the two different, the federation and the storage service, there's going to be some situations where it seems to me like you'd want the storage service to answer the question. Is that something that can be done, or do you actually have to duplicate all of that inside Pelican configuration?
No, well, once it is authorized at the Pelican level, that is the authorization decision. Now we might make a second, how do we interact with the storage service? And that might actually involve things that we direct. I skipped over the block of text. That might involve things about, we might make that decision based on the information in the token. We might make that decision based on the path. There are multiple ways we might make that mapping, but the vision is the authorization policy has to be told to the data federation. And that becomes important because we need to make sure we can replicate that same authorization decision both at the origin and also at the caches, because at the cache level, we don't have the object store to fall back on.
Thanks.
All right, in the back.
Yeah, I was gonna say, I think we haven't heard from Benedict yet.
He asked a
So-
question
so yeah,
earlier, but
sorry.
Benny Riedel from UW. Do we need to use side tokens, or can we just use whatever JWT that our system spits out?
It's going to need to be compatible with the site token library. So probably, yes, you'll need to do site tokens. That said, we have different mechanisms to integrate with your existing setup. So you don't need to say, in your case, teach Keycloak how to create site tokens, but we use OA for MP from NCSA that can plug into the Keycloak. So don't go throwing away things you have, but yeah, it will need to be.
Stefan from Purdue again. On the trust issue, Brian, you didn't mention VOMS, our virtual organization membership system that we have had for tens of years now, right? Is it on purpose, or you just wanted to save us from boring details, or do you use something else?
Yeah, we actually do carry around some X509 VOM support for LIGO, which they asked us to not shut off during their operating run. But they've given us thumbs up after LIGO 04 finishes, so June 2025. We're going to start pulling that out. This sort of authorization infrastructure, there's many reasons, doesn't mesh well with kind of the X509 approach. So there is a bit there, but it is really just a bridging feature to get to the token ecosystem for some folks.
So probably something you've already thought about, but as I consider it, when you're registering a new namespace, you had mentioned you can still CI log on to basically associate ownership with the new namespace for authorization decisions, things of that nature subsequent. How do you transfer, and do you support the idea of a support user or support group as people come and go? I'm sitting here thinking of, you might have multiple people at multiple institutions associated with a support group for a namespace to authorize new things.
Yeah, so that's why I kind of drew the business logic somewhat ambiguously. And the vision is we have a couple simple policies right now. Of course, everything can be overridden by admins, right? And this is something that we want to involve and approve. Another example of things that we're going to need as you have more origins come up is a way for one origin to say, hey, I'm working with this other guy, so I have key XYZ, but I also authorize ABC to work with me as well. So there's simple business logic right now. In fact, there's even a simple mode you can set where it's just basically first come, first serve, first key that asks for the name gets the name. There's also an approval workflow, and I think as the project matures, we're going to have more and more different workflows that people can implement.
As long as you're not paying yourself.
I saw the mic travel to the middle of the room.
Ron Tapia, PSU. Is there any plan to percolate authorization, authentication decisions through the HTTP headers so that clients can know if there's a problem with say a cache's certificate expiring or being valid or something?
Yeah, so that does we want to go through the HTTP headers, but right now the responses are, let's say, disappointing. It just says permission denied. Why is permission denied? I'm not telling you. We, as we say, always have opportunities to make some of the responses better. And actually every other week we work with the facilitation team look through all the error messages that the client has generated in the last week and try to knock off a couple that are poorly written, that are confusing, that just stink. So we want to continuously have some effort to make the error cases better. And yeah, right now you get permission denied.
All right, we have time for one more if
One
it's
more.
quick.
Kurt Dodds, University of Hawaii. In your cache miss scenario, the cache gets redirected to the origin
Mhm.
to download. Is there logic to redirect the cache to a nearby cache where the data sits? Because we don't want to always have to come to Hawaii to, right?
Yeah, Ming, is that a pull request or is that implement or merged yet?
On the mic, on the mic.
Must be by next release.
Yeah, so that's kind of very obviously something to work on and yeah, should be there next a first version should be their next release, which means that it'll start to mature over the course of the rest of the summer. But again, this is a wonderful thing about having the resources to improve this ecosystem. We can look at obvious things like that and say, hey, we should go implement that and climb that tree.
All right, thank you, Brian.